You know how your favorite websites just pop up instantly? Ever wonder how that happens? Well, today we're pulling back the curtain on the secret sauce that makes it all possible. We're talking about caching, the true unsung hero of the internet. But hey, before we get to the solution, let's really nail down the problem it's trying to solve. Just think for a second. What's the one thing that makes everybody want to throw their phone across the room when they're online? Yup, you got it. Waiting, that little spinning wheel of death, the blank white page, that agonizing pause between when you click on something and when anything actually happens. It is the absolute universal pain point of the web. And look, this isn't just you being impatient. For any website or app out there, this waiting game has a real tangible cost. We're talking serious user frustration, people just giving up and leaving. That's what we call a bounce rate, and just an all-around bad experience. And there's actually a technical name for this delay. And that name is latency. All it really means is the time it takes for your click to travel, sometimes thousands of miles, to a server, for that server to figure out what you want, and for the answer to travel all the way back to you. It's basically digital travel time. So, the big question is, how do we fight this? How do we crush latency and make the internet feel instantaneous? Well, developers have a secret weapon up their sleeve, and it's called caching. Now, at its core, caching is a brilliantly simple idea. Instead of going all the way back to the main source, the slow, faraway library, every single time you want the same piece of info, you just keep a copy of it somewhere much closer and much faster. It's exactly like keeping your favorite book on your nightstand instead of running to the library every night. Simple, right? Okay, to really see the magic here, let's walk through what happens the very first time you ask for something. This is what we call a cache miss. Your application goes to check the cache, the nightstand, and it's empty. So it has to take the long road, all the way to the database, the library. It gets the data, but here's the clever part. On the way back, it drops a copy into the cache before it gives it to you. It's planning ahead. And this is where the payoff happens. The next time you ask for that exact same piece of data, boom, you get a cache hit. The app checks the cache, finds it right there, and serves it to you instantly. Just look at that. We've sliced out all those extra steps. The whole long trip to the database, completely gone. It is a massive, massive shortcut. Okay, so caching isn't just one single trick. It's more like a whole strategy with different layers. Let's break down the three main ways it's done. First up, we've got client-side caching. This is the layer that's closest to home. It's happening right there in your web browser or on your device. Think of it like a personal desk drawer. It's the absolute fastest place to grab things you use constantly. So this is perfect for what we call static assets, things that pretty much never change, like a company's logo or the basic style sheet that makes a website look the way it does. By keeping these on your machine, your browser doesn't have to keep downloading them over and over again. Now, the downside? It's not so great for things that are constantly changing, like a news feed. All right, let's go one level deeper. Now we're at server-side caching. So, if the browser cache is your personal desk drawer, you can think of this as the main office supply closet. It's a bigger, shared resource that lives on the application's server, holding all the most frequently requested information for everyone. This is where you'd store something like the results of a really complicated database search that lots of people are running. And to make it crazy fast, we use in-memory tools like Redis or Memcached. These store data in the computer's super fast RAM, not on a slower disk drive. This is an absolute lifesaver for the back-end database, preventing it from getting totally overwhelmed. And finally, we've got the global play, edge caching. This is usually done with something called a content delivery network, or a CDN. The analogy here is perfect. Think of it like a global chain of convenience stores. Instead of having one giant central supermarket in one city, you have thousands of smaller stores all over the world, each one stocked with the most popular items for that specific neighborhood. So a CDN basically takes copies of your content, especially the big stuff, like videos or high-res images, and places them on servers all across the globe. That way, if you're in Tokyo trying to watch a video, you're getting it from a server right there in Tokyo, not from one halfway around the world in New York. This absolutely crushes the latency caused by the speed of light and physical distance. Okay, so all this theory is great, but what does it actually look like in the real world? Let's take a look at a practical example to see just how dramatic the impact of caching can be. All right, picture this. A tweet goes viral. Suddenly, millions of people are trying to see it. Without a cache, every single one of those requests would slam the main database. Your response times would just skyrocket, maybe to 200 milliseconds or even more. But with a server-side cache like Redis in place, that popular tweet is served from lightning-fast memory. And look at that, the response time just plummets. And this isn't just a hypothetical. Some research from 2023 found that using in-memory caching can improve application response time by up to, get this, 62.6%. That is a huge, tangible improvement that users can actually feel. All of that is thanks to simply not having to make that long trip to the database every single time. But it's not all magic. There is a catch. Caching introduces a brand new, tricky challenge. What happens when the original data changes? You can't be serving old, stale information, and this brings us to the really crucial concept of keeping the cache fresh. See, caches can't hold everything forever. They have limited space, so they need a set of rules for what to throw out to make room. These are called eviction policies. A couple of really common ones are LRU, or least recently used. It's pretty smart. It basically assumes that if you haven't touched an item in a while, you probably won't need it again soon. Then you've got FIFO, or first in, first out. It's much simpler. It just kicks out the oldest item, no matter how popular it might be. Picking the right policy is actually a huge part of a smart caching strategy. All right, so we've looked at the problem, latency. We've seen the solution, caching, and we've walked through the different strategies you can use. So let's tie this all together. And here's the most important takeaway. The really effective, high-performance applications out there, they don't just pick one of these strategies. They're not mutually exclusive. The best solutions use them all, layering them together. They'll cache static files in your browser, they'll cache database results on the server, and they'll serve global content from the edge. It's this combined, multi-layered approach that creates a nearly impenetrable defense against latency. And that really brings us back to the core truth of this whole thing. At the end of the day, all of this complex engineering, all these different layers and policies, they all serve one single purpose: delivering a fast, fluid, and totally seamless experience for you, the user. So caching has been this incredible solution to one of the internet's biggest speed bumps. But, as our digital world gets even more complex and our expectations for instant just keep getting higher, it leaves us with a pretty fascinating question to think about. What's the next big bottleneck we're going to have to engineer our way around?